About that, who works with AI search as well? Okay, then. I hope that you learn what we're talking here today. This is just to tell you about a story that happened last year with one of the projects that I worked. We was very ambitious that we was trying to deliver like new updates on AI search. We have a timeline of 1 month to build this thing. Then everything that I showed to you here happens in 1 month only. And the idea is understanding a query from users. Like we want to evolve our search engine at this point in time and start using natural language textual information and be able to do some more broad search and learn with that with our users. The challenge here is like we need to have a low response time. We will provide to real users and needs to be very accurate, the results that we are creating. And we want to explore different types of solutions that we'll talk very soon. And we want to answer this type of query, like I want 4 beds, 2 baths, house in X and Y, and want to extract this information and do the search, right? To this happens, like we need to think about what the possible solutions that they can solve this problem in 1 month time frame. We have a lot of pressure to make sure that we can detect the right solution. Basically, you can go 2 routes, there is others, but one is try to do the query understanding, then we can get the natural language and try to understand and try to plug in some traditional search. Or we can work in the retrieval using semantic search, like embeddings, and try to solve them. Then, if you're talking about query understanding, we can try to use classic NER, like name entity recognition, like CRFs and other probabilistic models, Markov chain, etc. Or we can go to the new age of AI that use LLMs to extract this output. Just to remember, this was done 1 year ago. Then some techniques that I will say here already has other ways to solve that I will comment next. And the idea is to use LLMs is to give them the full raw text and ask them the structure for me in some nice format. And in the other part, using the retrieval, we can use a vector search, vectorize the input, and index using some LLM or embeddings model in this case. Could be like a big one or mini ones. And other ways use REA or using a hybrid approach. In your case, just to comment, like we decided to go with LLM extractions. And we try a lot of different tools available out there. There is open source like that you can use, but we identified that this solution was not scaling for our needs. But I'll explain more very soon. But one thing that we learned, like we have 1 month to deliver the solution, then we use some approach like this at the time. When you start a project, you can use open source models, but one suggestion is start with commercial models out of the box and test like which one will work for your case fast. Fail fast and then move to other models if you need, because you need to test if you're able to do that. Then we started testing commercial models like the Google, OpenAI, Anthropic at the time to see which one could perform. And then you start to test later open source models. And in last case, using a fine-tuned version of models. Then we try to do the proof of concept using a third-party model. And later we identify that we need to create our own model for that. But to detect that, first we try to do some benchmarks. This is not up to date, but just to highlight some benchmarks that we use at the time. Always check for that to understand which model you should use. And after selecting a few of the models, analyzing what is available, we create an offline evaluation framework to make sure that it's consistent. This type of LLMs. We need to create a data set that's representative enough from the queries that you want to test, that we translate as input the natural language to a structured JSON output. And then we analyze, after having this ground truth, run the models and create a lot of statistics to analyze like when the model generates the format is 100% compatible with JSON format, have all the fields there, and also the attribute is correct. Takes some time to do, but after you set that, makes much easier to test different types of models. But what happens during the process, like here I shortened the whole story. We start with the commercial models first, but 1 year ago, when we started doing that, the model was not so stable as is today, and you need to pay a lot if you want to have dedicated instances. The response time to run this model was around 4 to 8 seconds, and was not ensured that we can deliver a very powerful search. Then what we have done was testing the open source models, and we saw that was not working with our data because they are too generic. Then we went to the step that we need to fine-tune some models. What we have done was trying to find a good framework to do this fine-tuning and try to identify which open source model can learn with our data and how we can put online to scale. Like we did some quantization as well to reduce the size of this model. After a lot of experimentations, I can say more than 200 different experiments, we could find out one that could reply in 1 second. That was much better than what we identified online. And I will talk more about that very soon. But to do the fine-tune experiment, we decided to use llama factor at the time. There is others available. It's very easy, and I will demonstrate very soon as well. We use the llama factor as the framework to do the fine-tuning part. We use GCP to run these models and train with Vertex AI, and we log everything in weight and bias at the time to have nice dashboards. We was looking during this time, during the model selection, models like Llama, Gamma, Gwen, among others, and looking for data quality, hack iteration, and efficiency to apply quantization, because doing that you can reduce the inference time to like 1 second as we tested. Okay, and then I will share a quick demo, just showing here the way that I did at the time and pass some insights about how we execute this type of activity. At the time, we was using Vertex AI Workbench, Llama, NVIDIA GPU, L4, because we want a little bit of VRAM, in this case 24, and it's quite cheap at this point. And let me go and show, like, I will go to my environment here, then access Vertex AI, go to Workbench. Let me find the instance. It's loading here. Let me find my instance here. Give me a second. I just create one in Singapore because it's where you have access to L4, that is 24 VRAM that you need to run this. And then one way to do that, access the machine by inside of it, then I can do a lot of experimentation. To be honest, terminal is my word. I like to just be very close to the code and code here. Then just put a session here, then if things drops, we can go back. I think I create a session for today. Oops. Yep. Okay, things that happen, let me go here to explain, like, we use the Llama factory. The good part about it is, like, if you want to fine-tune a model, it has access to a lot of models that you can do. Let me go to the features. It accesses a lot of the open source models that you need to fine-tune, then it's a very complete tool to do that. It offers different types of fine-tuning that you want to do. It offers, like, the keylogger, the one that you use at the time, and with this quantization technique as here. And how you install it if you need. Let me go to the session that they explain that. Basically, you need to make sure that you have Hugging Face login, because we will download this model, for example, from Hugging Face. Like in this case, we select a Gwen model. You can select any model here. And you need to, just select the model that you feel that works with your application. And you install the Llama Factor library. When you have, like, clone, you need to do a few things. First, create your data set. Let me show to you a little bit the format of data set that we create at the time. I think I put in some place around here. Yeah. Data set REA search. This data set is using, like, Llama format. Usually you have the system prompt, the instruction that you want to do, and the output. As you can see, The structure is based the raw text, like I'm looking for a rental property in Mountain Peninsula, and here's the format that you're looking to extract. The key part here, when you want to fine-tune these models, you don't need to have like thousands of examples exhaustive that you want to train, but just a few that they are diverse to make sure that you cover different craze. That's one thing that I noticed when you use this model. You can train this model quite fast, around 30 minutes with this type of hardware, and then it can converge very fast. The good part is like the model is learning organically how to get your how input and translate to the structure format. You have today other ways to do that, but I not see something so fast as this one. Then sometimes you want to have some of these tools, but there is trade-offs that you need to apply. Then I will keep the data here. We can check later. And other thing that you need, like when you have your data, here I use Llama format, but there is others that you can change. Let me go again to the folder. Okay, another thing that you need is have your YAML file. If you check the documentation, let me show very quick. There is a part with examples. If you are kind of lost, in the example session, it shows like if I want to run the Llama factory, I just need to use this command, train, and my Llama YML file. And here, you can just copy one of those as examples. I just did that to speed up the process. Then you need to set up your data set. In this case, is the one above. You can select how you want to train this model, which model that you want to use. Like this one is the one that we got on Hugging Face. You can fine-tune any type of model very easily. And you have a lot of parameters to play. That's the hard part. That's why I told that to run two or more hundred experiments, just to make sure that we understand what we need. Here is just a simple example. I select one of these models, then set the configuration file, and then let me go back. I think we can train on the fly one of this model, just to show here. Yeah, not going correctly. Oops. Yep. Cool. Let me go to run training. Yeah, basically what is in the documentation. Llama factory train, we modeled the model using LoRa technique. And then if I put run, it should start for us. First time, you need to log into Hugging Face, and also it will download the model for the first time. What I like to do if I'm monitoring this close is open some things to monitor if everything's all right. Yeah, NVIDIA as well, to see the GPU working. And then, I forgot the number here. This is just to make sure that's fresh in this command. Then you can check like how the GPU is being used. Then you let the show happens here. Here saying that I can train, there is 8,000 examples in less than 20 minutes, just to have idea how this type of components work. And that's it, like this is what you need to do, like few steps, and you have this done. We integrate with weight and bias. It's very simple. You just provide the key, and you log everything inside of this framework. This helps a lot. I will show one of the dashboards about this. And then going back, like, let's show the results a little bit, just to comment about this. We try to use Gwen 2.5 in one of our rounds, and we try different size of parameters, like 500 million until 32 billion. You can train in a single GPU like that one. You can fit that. The method is very efficient. And we train at the time with 10K natural text, the format that you want to try, and try different things like quantization, batch size, gradient, etc. In these three images here, 3 rows, you can see difference between different size of model. As we increase, the first, I know that's hard to read, but the thing is like we are varying 2 things here. And as we increase the size, the results improve. We reach, in the first round, I think I put here, 86% of precision, like when we start in testing. After just a few refinements, we reach 96% of precision, like of extraction. For comparison, if you use OpenAI at the time was 95%. Like this model even can be better than what you find outside. Generation of JSON 99% completion, correct? And average time less than 1 second. If you use OpenAI other tools, 4 to 8 seconds. At this time that we did the experiment, today the models evolved. But was very useful because after that we could put online and use like to serve our users. Today the solution is running online with this model like as it is, and we're collecting a lot of feedbacks. Then just to summarize, my suggestion, if you want to fine-tune something, don't start with that. Just start with third-party LLMs. Today you have a feature called structure output that you create a pydantic class, and you can do the same thing, but it's not organically like that model embedded inside of the learning. But it's a great way to start, just to test your product and make sure that you are reaching the result that you want. Builder offline framework is very essential, independently the solution that you're using. This speed ups your tests because you are consistent analyzing different versions of model. Then makes it very easy to decide which model you want to use. Fine tune only when justified. But here today the purpose is to show you that's possible. It's not hard, but depends on your case. The complex part is like, after you have the model, you need to serve, then thinking well before doing that. Also do some back of envelope cost to see which one worths more. Depends on the complexity of your solution. Sometimes you need a more smart model. It's very costly. Depends the number of requests, the input size, and the output counts a lot. Also take care because LLMs evolve quite fast. Today we are talking about this, but tomorrow they can release all the things that make this obsolete. Yeah, and last thing is experiment with real users because we got a lot of insights when you put this online and saw the flaws of the model and keep updating, like for other types of query that we need to solve for them. But it was a very great experience at the time. And last thing, yeah, we are hiring. I think we talked before. We have a lot of some data scientists, machine learning position, different teams, AI search, recommendations, agentic AI. If you're interested, yeah, please follow the link or find me on LinkedIn. Yeah, that's it. Sorry? Yes.
Does anyone have any?
What size model did you kind of land on when you tested different ones?
Yeah, I think the best one that have the good trade-off was 7 billion at the time. I think we could, yeah, the key part was using not only quantization, but use a specific technique of quantization that's AWQ. This proves to be superior for us. And I was challenged when you do that, the precision can drop, then we need to, like, maybe we need to add this example. There's other things that we did. Usually, we have an internal query engine that goes to our search engine. We decided to create a semantic layer as well, that the query engine was more machine related. We created a middle layer just to facilitate the semantics around this translation. The model improves a lot out as well. But yeah, it was very fascinating to see the model evolving during this process. That's a good point. When you say API, you're talking the search API that we connect, right? I think at this moment, this API was created many years ago. It's very mature. Then we not have too much frequent change. But if that happens, we need to understand, like, if it's a new field, or if it's a modification, something that we have, or if we remove, then we need to hit train. After identifying the good parameters and the range, the batch size, the gradient parameters, becomes easy to hit train. Like we don't need to do this full process. We just did because we put a lot of models to run in parallel. But yeah, you need to hit train at some point. Cool. Most of the time was precision, but precision in different levels. I think I don't have the picture, but usually like you have the full document is one precision, and then let's say in the properties website, you can select like attributes of the house. Then the attribute itself is one second level, and then the third level is like which attributes you want to classify. We analyze everything and then do a linear combination to have an average of them, but we analyze many of them. Then final result, most of them was 90%, and the average was 96. Yeah.
Thank you.
Oh, thank you.
Thank you. This is small.